This is the General Motors Proving Ground, where dramatic and punishing action is a main attraction. Here, new cars, trucks, and buses are put through extensive, grueling, and brutal engineering tests and evaluations to make certain they perform the way they were designed to perform. This is the final big test before new vehicles are approved for production. The first automotive proving ground in the world was built by General Motors in 1924 at Milford in southeastern Michigan near Detroit. Vehicles were simpler then, and so was the testing. Today, testing is extremely complex because vehicles have become so complex and because of increased customer demands for high-quality transportation that is dependable, economical, and comfortable, as well as safe and environmentally acceptable. Meeting these demands has required dramatic and revolutionary changes in automobile design and in test equipment and procedures. But long before the final big test at the proving ground, years of research and development work have been completed. At the General Motors Technical Center, a variety of activities in research, engineering, design, and manufacturing are carried on to introduce improved shapes, materials, and components. And the high technology of the modern car, in electronics for example, must be matched by increasing sophistication of test equipment. Making car and trucks easier to service is an important element of advanced vehicle design carried on at the Technical Center. The goal is to be sure service technicians and independent garagemen are familiar with new GM products and their repairability. The new split-engine cradle, for example, allows easy access for servicing the engine, transmission, steering system, and rear crossmember. GM's cradle design also allows the entire engine, transmission, driveline assembly to be removed from the vehicle and serviced as a unit. This simplifies many complex powertrain service operations. A new car concept first takes shape in designer's clay, and its dimensions are entered into a computer. The car is then built in the computer. In effect, an electronic car is generated with electronic components. This permits the engineers to run tests that predict how the actual parts will operate. The design is refined before any hardware is actually built. Testing of component parts is an exhaustive effort carried out by each of the car and truck division test laboratories. Components undergo grueling abuse far beyond what can be expected for the average car over its lifetime. Another critical area in car design is aerodynamics testing. This huge wind tunnel provides important answers in the designer's goal of minimizing wind resistance and improving fuel economy. Then, after years of research and development, new products are ready for the final big test at the proving grounds. Reliability of performance is a major goal, to see that the 15,000 parts of a modern motor vehicle work together properly under the widest possible variety of conditions. One of the most dramatic recent trends in auto design has been the change to smaller, fuel-efficient vehicles with front-wheel drive. Increased use of diesel engines and advanced electronic monitoring and control systems to improve drivability and control emissions. Onboard computers also are evaluated as a built-in diagnostic tool to simplify service work. New designs of all types must be evaluated promptly and effectively on prototype cars before the vehicles are approved for manufacturing. And the changes must also be monitored on production cars to be sure they are performing as designed. The proving ground at Milford, Michigan is the nucleus of an elaborate engineering test and evaluation network that extends around the world. At Milford, there are more than 123 miles of carefully designed test roads. Testing on the road is evaluated by highly sophisticated laboratory test equipment and procedures. Complex instrumentation with applications using microprocessors, lasers, and fiber optics is constantly extending the state of the art. This is vital as cars and trucks continue to become more complex. In Mesa, Arizona, near Phoenix, engineers conduct year-round hot weather testing at the Desert Proving Ground. Mesa is a 4,600-acre facility with 58 miles of special test roads and trails. Testing here at Mesa shows how cars and trucks operate in dust and in desert-type heat. At the High Altitude Test Facility at Denver, Colorado, the effects of high altitude on performance and emission control are measured. Not far away at the Mountain Test Facility in the Rockies, vehicles are driven up and down the long, steep grades of Pikes Peak to test engines, transmissions, brakes, steering, and other systems. Up in Kappas Casing at GM of Canada's Cold Weather Test Facility, vehicle performance is tested at winter temperatures that drop to 50 degrees below zero Fahrenheit. Other proving grounds are located abroad, in Australia, Brazil, Germany, and in Great Britain. GM cars and trucks designed, manufactured, and marketed abroad undergo testing that is similar to that carried out in the United States. Worldwide, tens of millions of miles are test driven by General Motors every year. At the Milford Proving Ground, driving schedules are based on real-world driving conditions, obtained from instruments in statistically selected owners' cars, taxi fleets, and police vehicles nationwide. These schedules make it possible to produce in a few months the same type of driving conditions that might result from 100,000 miles of actual driving experience. Thus, a vehicle's long-range susceptibility to wear can be quickly evaluated and necessary changes made. While a major aim of proving ground testing is to evaluate durability and reliability, test programs also concentrate on many other concerns. Heat and humidity chambers are used to simulate the conditions that create corrosion, to measure how the company's products react to years of exposure to corrosive environments. Engineers also work to reduce structural vibrations, monitoring unpleasant noises that may be heard inside the vehicle, to see if corrections can be made by changing vibrations or noise transmission characteristics. Special tests are designed to help increase tire traction and extend tire life. Some take place on proving ground roadways, and others involve dynamic laboratory equipment that simulates the effect of roadway forces and permits engineers to predict a tire's handling characteristics. Major efforts are devoted to the evaluation of passenger restraint systems. Engineers use highly advanced equipment, such as test sleds, to simulate accident conditions to seek continuing improvements in vehicle safety design. Other important tests involve the actual destruction of more than 300 vehicles every year at Milford alone. The proving grounds also play an important role in evaluating new vehicle design concepts for serviceability. A special test schedule helps ensure that new vehicle designs are compatible with existing towing equipment and practices. Other tests help ensure that new vehicles can be hoisted on standard lifts and jacks and are compatible with existing automatic car wash equipment. Crash tests of pre-production vehicles provide service engineers with real-life evidence of how to simplify collision repairs of new vehicles. Their efforts lead to the design of body and understructure features that are easier to straighten, and to the development of new repair procedures and techniques. Fuel economy is another top priority, and the proving grounds play an important role here, too. The average fleet fuel economy of General Motors cars is being increased more than 2.5 times between 1974 and 1985. This has involved massive changes in basic vehicle design, more lightweight materials, and significant advances in automotive technology. And the results are verified by proving ground testing. Engineers have also run 50,000-mile exhaust emission tests on representative new model cars to be sure they meet U.S. government regulations. In addition to vehicle testing, proving ground research also concentrates on better, safer roadway design. Potential roadside hazards are set back from the edge of the road, or are specially designed to reduce the possibility of accidents. Research also concentrates on the driver, especially in the development of advanced training in handling driving emergencies. The driver, the highway, the vehicle. All are the subject of continuing study and evaluation at the GM Proving Grounds. It is a never-ending priority, the final big test. Its goal, to achieve ever higher standards of transportation for people and businesses all over the world.